Assalamualaikum and hello everyone. We are from section 10 group 1 want to present our video on how to solve problem using linear programming in Excel. And here are our group members.
Okay, Assalamualaikum. My name is Aiza. I'm going to be a first presenter to solve this problem in this question. Want to know how many acres of each crop should the farmer plant to maximize the profit. Okay. Now I want to classify X as a lead, second, which is Y, prior to on. Okay. So I'm gonna do table. They do like this. X, which is reach, and Y, which is also Y, on, and I want to divide per table, which is labor in minute, sorry, not in minute, but per hour, okay. Secondly, capital in dollar, okay. Profit, because the patient want to know the profit of the farmer that she will get out. So, the labor, 4 hours, right? 4, so means like 4, 4x. And meanwhile, corn is 16. 16y. How about capital? Capital. So the capital say the and let say that in the equation 20 of capital. So we write here capital 20 capital and in corn also 40 y. Don't forget to put your x and y here. So the profit of each wheat and corn is 80x and wheat, next one for wheat and for corn is 100y.
In this question, we need to maximize the objective function of 80x plus 100y. Next, I'm going to put the first equation as constraint 1, that is 4x plus 16y less than 800. And the second constraint is 20x plus 40y lesser than 2400. Next, I'm going to type the variable x and y up here. The objective function coefficient is 80 and 100. For the constraint 1, the input for x will become 4 and y will become 16, lesser than 800. For constraint 2, the input for x will become 20 and y will become 40, lesser than 2400. Next, I'm going to find points for drawing the constraints line. For constraint 1, or known as C1, I'm going to create a table for x and y values. So, when x is equal to 0 in C1, y will become 800 divided by 16, which is 50. And when y is equal to 0, x equal to 200. And again, I will put all of these numbers in borders.
So now I will continue with C2. For constraint 2, I'm going to create a table for x and y value first. So when x is 0 in C2, y 2400 divided by 40 is equal to 60. And when y is equal to 0, x just equal to 120. When 2400 divided by 20.
To begin drawing graph, I'm just going to highlight constraint 1 points, then click insert, then click scatter, then select scatter with straight lines and markers. Next, I'm going to right click on the graph and click select data. I'm going to click series 1 and click edit. Series name, I just type C1 for constraint 1. Next, I'm going to delete series X values and replace it with 0 and 100 here. I'm going to delete series Y values as well and replace with 50 and 0 here and click OK. For constraint 2, I'm going to click add to do the same as C1. Next, I'm going to label the constraints by clicking on Insert, Shapes, and then Text. Click and type C1. Repeat the text for other constraints. Next, we find the feasible region. Note that C1 is a less than constraint, so it is satisfied here below the line as well as C2. Judging by the direction of the arrows, we can see that feasible region is here. So I'm going to add the text box and label the region feasible region. Next, I'm going to shape the feasible region. Click Insert, Shapes, and then select the freeform. Next, I will click on one of the corners, move and click on the second one, and then third and fourth. And move my cursor to the beginning point to close it off. To make the shape transparent, I will right click on the shape and click Format Shape, click Fill and increase transparency. Next, I will label the corner point as A, B, C, and D.
Okay, now we are ready to find the coordinates of the extreme points. First, point A. At point A, we can obviously see that the coordinates for A, x is 0 and y is 50. So, first I would type x, y, and z. I will color x and y for the yellow, and then z for other color, blue. Okay, this x will be 0, y will be 50. Okay, at point B, there are two lines that intersect, which is C1 and C2. So all we have to do is to copy paste these constraints, paste it here, and then I will do the same things, which is I will write the coordinates x, y, and z. Okay, now to find the coordinate at point B, select these two yellow cells, then type equal m mul, which is matrix multiply. Open bracket, type m inverse, open bracket, then select two coefficients, close brackets, comma, and then select
the right hand side of the constraints and then close the brackets. Don't just type enter. What we do here is hold down the control button and hold down the shift button and then press enter. There you go. So this is the coordinates at point B. Okay, now we are going to find the coordinates for point C. For point C, we already know that the constraints to have a coordinates which is 120 for x, 0 for y. So these constraints we are going to put here 120. So we just have to type 120. So I would like to copy paste the x, y, and z at point C. At point C, so we can clearly see that the value of x is 120 and y is 0. Same for the point D. I will type first point D. At point D, we can clearly see that the coordinate of x is 0 and y also 0. Okay, the next step is we are going to calculate the value of z for each point. The objective is to maximize 80x plus 100y. Okay, now we want to find the value of z. We types equal 80 times x at point A, which is 0, plus 100 times the value of y, which is 50, and then type enter. So the value of z at point A is 5000. Then all we need to do is copy paste this cell, paste it to the other point so that we can get the value of others point. Since this is a maximization problem, so the optimal solution will be occurs at point C, which is the value of z 9600, and it is x equals to 120 and y equal to 0. So the corresponding maximized value of the function is 9600. And that's conclude this video. Thank you for watching.
That's all from us. Thank you. I hope you guys enjoy.